Hello everyone, this is Mr. Mefford again, and this week I'm leading our lesson on stoichiometry, specifically solving mass-to-mass problems. Stoichiometry is the unit that uses our molar conversion triangle of science. We first used this in Unit 9 when we studied the mole. If you recall, in Unit 9, we gave you an amount of a chemical. Like perhaps we gave you the amount in grams, or we gave you the number of particles, the number of atoms or molecules, or we gave you the volume of a chemical in liters, and we asked you to convert the given amount of a chemical to a different unit of measurement for that chemical. For example, we gave you grams, asked you to change grams of the chemical to liters of that chemical. We gave you liters and we asked you to solve for how many particles of a given chemical are in that amount of liters. So now in stoichiometry, we actually use two of these molar conversion triangles of science. We use two of these because in stoichiometry, we compare two different chemicals. We can call one of them chemical A, and the other triangle is for chemical B. These two chemicals, chemical A and chemical B, are two chemicals in the same balanced chemical equation. And the two chemicals are related through their mole-to-mole ratios. So this is the key to Unit 11, stoichiometry. And last week, we began studying mole-to-mole ratios when we looked at the BLT with cheese club sandwich, when you guys answered questions around this model. In this model, we see that a bacon, lettuce, tomato with cheese club sandwich is made up of 3 slices of bread, 1 slice of cheese, 1 slice of tomato, 1 piece of lettuce, and 2 slices of bacon, and together those make 1 BLT with cheese club sandwich. Now these big numbers we wrote, these coefficients, in chemistry in a balanced equation, they represent the number of moles of the given chemical. In this example, they equal just how many pieces make up the sandwich. And last week when you compared two of the ingredients, for example, 3 slices of bread to 1 slice of cheese. That's an example of a mole-to-mole ratio. 3 moles of bread is equal to 1 mole of cheese. Or 1 mole of cheese is equal to 1 mole of tomato. Or 1 mole of tomato is equal to 1 mole of lettuce. Or 1 mole of lettuce is equal to 2 moles of bacon. Or 3 moles of bread is equal to 2 moles of bacon. Last week was building the foundation for using mole-to-mole ratios. If we look at the triangle together, both molar conversion triangles of science, we have this, where you see in the middle we use the mole-to-mole ratio. Moles of chemical B over moles of chemical A, or moles of chemical A over moles of chemical B, depending on which direction you're moving. Are you moving from chemical A to chemical B? Use the top conversion ratio. If you're going from chemical B to chemical A, use the bottom conversion ratio. So this will be in your homework assignment for this week, and we'll come back to it. Let's do a practice problem. Let me model how to solve a mass-to-mass problem. Here we have a balanced chemical reaction. And this chemical reaction, this is one that every chemistry teacher at West uses. This is how we generate hydrogen gas for demonstration. See this? We have solid zinc metal, clear colorless hydrochloric acid solution. When they come in contact, bubbles are formed. Inside the bubbles are hydrogen gas, and the zinc disappears. Really what's happening is it's dissolving and becoming part of this solution, and a zinc ion in this solution. You may recognize this as a single replacement reaction where the metallic zinc replaces the metal in the compound hydrogen. So a mole-to-mole problem, a mass-to-mass problem would look something like this. Number 3 in this week's homework assignment is the problem I'm going to do. Number 3 in this week's homework assignment says that the reaction that chemistry teachers usually use to produce hydrogen gas, H2, is shown below, and that's the equation we just went over. So now the question is, how many grams of hydrochloric acid is needed to produce 1,000.0 grams of hydrogen gas? So if I make this larger, it's asking if we want to produce 1,000.0 grams of hydrogen gas, how much zinc, how many grams of zinc are we going to help us solve a mass-to-mass stoichiometry problem? We're going to use the molar conversion triangles of science. Now, if we use this, eventually, after using this long enough, you'll likely find that you can solve these problems without using this scaffold, without using this tool. But for now, I'm going to use this tool to help me solve this problem. So if we look at the chemicals here, we're going to call zinc chemical A, and I'm going to call hydrogen gas chemical B, because zinc's on the left and hydrogen gas is on the right. So I'm going to write here, chemical B is hydrogen gas, chemical A is solid zinc. Now, I personally like to identify where I'm starting and where I'm ending in the molar conversion triangles of science. So we are starting at grams of hydrogen gas. They give us 1,000.0 grams. So we are starting here at mass of hydrogen gas. And we want to end up over here at grams of zinc. So we're going to start here and we're going to end up here. Now if I follow the arrows, we're going to, first step, multiply by this conversion ratio. That's going to take us to moles of hydrogen gas. Then we're going to multiply by this conversion ratio. I'm just following the red arrows to convert moles of hydrogen gas to moles of zinc, solid zinc here. Then to convert moles of solid zinc to grams of solid zinc, we're going to multiply by this conversion ratio. So this problem is going to be a 3-step problem. Start with grams. Step 1, multiply by this conversion ratio to get moles. Step 2, multiply by this conversion ratio to get moles of zinc. Step 3, multiply by this conversion ratio to end up with grams of zinc, to change moles of zinc to grams of zinc. So it's a 3-step problem. Now let me show you how I would write that. I'm going to start with what is given, 1,000.0 grams of hydrogen gas. And I'm going to make that a fraction by writing it over 1. Now I need to multiply 1,000.0 grams times a conversion ratio that's going to allow me to change grams to moles. and that is this conversion ratio right here. I'm going to write 1.00 moles of hydrogen on top, and on the bottom I'm going to write the molar mass of hydrogen. So 1.00 moles of hydrogen gas on top, and on the bottom I need the molar mass of hydrogen gas. Now, we did molar masses while we were still in school, and remember, molar mass is just the atomic mass written on the periodic table, the average atomic mass in grams. So for hydrogen, it's 1.008, and then we just write grams at the end. So if hydrogen is 1.008 grams, let me write that here. So hydrogen is 1.008 grams, but this is just 1 mole of hydrogen atoms. What we need is hydrogen 2, which is a diatomic element, a diatomic molecule. So we actually need 2 moles of hydrogen atoms to get the molar mass of 1 mole of diatomic hydrogen molecules. So we just add this up and we get 2.016 grams. So the molar mass of hydrogen, elemental hydrogen, is 2.016 grams. I'm going to write that here, 2.016 grams of hydrogen as its molar mass. Next step. Now, if we stop right now, if we just write equals and multiply and divide, we will have changed grams of hydrogen of H2 to moles of H2. Now we need to change moles of H2 to moles of zinc. And we do that by multiplying by the molar ratio, or mole to mole ratio. And it says here that we need to write the moles of chemical A is zinc, over moles of chemical B. Chemical B is hydrogen. And we get the number of moles from the balanced equation. And that's what we see here. Moles of zinc is written there. Now, you need to recall that if a coefficient isn't written, if a number is not written in front of the formula, then the number is 1. The coefficient is 1. So this is invisible coefficient 1, and there's an invisible coefficient 1 here also. And there's an invisible coefficient 1 in front of the zinc 2 chloride. So the mole to mole ratio, we need moles of zinc over moles of hydrogen. Moles of zinc, 1. Moles of hydrogen, 1. That is the mole to mole ratio. Next step. This is a 3-step problem, so we have one more step. So if we stop right now, we can cancel out some of our units here. We have grams of hydrogen, H2 on top, and we have grams of H2 on bottom. Remember, if you have the same unit on top and bottom, you can cancel them out. And we can cancel these out, moles of H2 on top, moles of H2 on bottom. So we can cancel those units out. So if we were to stop right now, our answer would be in moles of zinc. And that's where we are. If we look at our roadmap, we are right here, moles of solid zinc. We've changed grams of hydrogen to moles of zinc. We need to multiply by one more conversion ratio. We need to change moles of zinc to grams of zinc. And we do that by multiplying by zinc's molar mass on top over 1.00 moles. So I'm going to write that here. 1.00 moles of zinc, and we need the molar mass of zinc on top. To do that, get out the periodic table, and we see right here that the molar mass of zinc is 65.38 grams. 65.38 grams of zinc. Now, before we do any calculations, let's cancel out units. Moles of zinc on top, moles of zinc on bottom. And right now we can double check. Our units inform us that we are doing the problem correctly. Right now, the only units left are grams of zinc. And that's the question. The question asks us to solve for grams of zinc. So by canceling out units, we know that we can stop setting up the problem now. We know that we've done it correctly. Units of measurement may seem like a pain in the butt now, but eventually you'll get to the point where you'll like units of measurement because the units are very useful. They're useful because they tell you that you're setting up the problem correctly. So now we're going to do our calculations. Now we multiply all of the top numbers together, and we're going to write that amount right here. So I do 1000.0 times 1.00 times 1 times 65.38, and I get the amount I'm going to write on top, 65380, and on bottom we multiply all of the bottom numbers together. 1 times 2.016 times 1 times 1.00, and that is 2.016. And now a fraction means take the top number and divide by the bottom number. So we have 65380 divided by 2.016, and our answer ends up having many, many digits. So at this point, let me write our answer here. 32430.55556. The units of measurement are grams of zinc. So now what we need to do is round our answer to the correct number of significant figures. To do that, we go back to all of our measurements and we count their significant figures. 1, 2, 3, 4, 5 significant figures. 1, 2, 3 significant figures. 1, 2, 3, 4 significant figures. These are not measurements. The mole to mole ratio is not a measurement, so we ignore those. Here, 1, 2, 3, 4 significant figures. 1, 2, 3 significant figures. So now that we've counted up the number of significant figures in all of our measurements, we round to the fewest number of significant figures, which here would be 3. We have a tie for 3. So we're going to round our final answer to 3 significant figures. 1, 2, 3. So the 4 is the digit we're going to round. We look to the digit to the right. It's 3. 3 is less than 5. So our answer will be, we'll keep the 3, keep the 2, round down the 4. So keep the 4 and then put zeros in. So our answer is 32,400 grams of zinc. If we wanted to produce 1,000 grams of hydrogen gas, we would need to react 32,400 grams of zinc. And that is problem number 3 in this week's homework assignment. If this all makes sense and you feel confident doing this week's assignment, you're welcome to stop the video here. For those of you who are going to stick around, I'm going to do one more practice problem. Let's look at one more practice problem. We'll keep the same equation, the same zinc plus hydrochloric acid yields hydrogen gas plus zinc 2 chloride. So you just keep the same equation, but this time let's move the quantities around. Let's say you're starting with 1,000.0 grams of hydrochloric acid. And this time we want to solve for how many grams of hydrogen gas would we produce in this problem. Now, looking at the molar conversion triangles of science, chemical A is this, in this example, is going to be hydrochloric acid. So chemical A is hydrochloric acid. Chemical B is hydrogen gas. So we're going to start at grams of hydrochloric acid. We're going to start here, and we want to end up at grams of hydrogen gas over here. So we're going to begin by first multiplying by this conversion ratio. Then following the arrow, we're going to multiply by this conversion ratio, the mole to mole ratio. Then following the arrows, we're going to multiply by this conversion ratio, and that's going to give us grams of hydrogen gas. So I'll quickly run through this. One 1,000.0 grams of hydrochloric acid, make that a fraction over 1. First conversion ratio is the molar mass of hydrochloric acid. That is, I'm looking up chlorine here. Chlorine is 35.45 grams. So 35.45 grams plus 1.008 grams. And that is 36.458 grams. That is hydrochloric acid. Now canceling the units, grams hydrochloric acid, grams hydrochloric acid. Now we are at moles of hydrochloric acid. The next step is the mole to mole ratio. Looking at our molar conversion, now we need this mole to mole ratio. Chemical B, hydrogen, is going on top. Chemical A, hydrochloric acid, on bottom. So we said hydrogen goes on top, 1 mole of hydrogen, and I get the 1 from the coefficient. On bottom, 2 moles of hydrochloric acid. Now before multiplying by the last conversion ratio, moles hydrochloric acid, moles hydrochloric acid. So the last step is to convert moles of hydrogen, 1.00 moles of hydrogen, to grams of hydrogen. So I need the molar mass of hydrogen, which is 2.016 grams of hydrogen. We can now cancel out moles of hydrogen, and now that we have the units of measurement we're looking for, we can multiply the top numbers together and divide by the bottom numbers. So 1,000.0 times 1.00 times 1 times 2.016, and we get 2,016 grams of hydrogen. Now we multiply the bottom numbers together. 1 times 36.458 times 2 times 1.00, and we get 72.916. Now we divide top number by bottom number. 2016 divided by 72.916, and our long answer has many digits in it, grams of hydrogen. So I round to the fewest number of significant figures. 5, 3, 4, 3, 5. and I ignore the coefficients because they're not measurements. So I'm going to round to 3 significant figures, 1, 2, 3. So I round the 6, and our final answer is 27.6 grams of hydrogen gas. So I wanted to show you another example which had a different mole to mole ratio. Sometimes the mole to mole ratio is 1 to 1, like we saw in the first problem involving hydrogen gas, the product, and zinc, metallic zinc, the reactant. And in the second problem, we see a mole to mole ratio of 2 moles of hydrochloric acid equals 1 mole of hydrogen gas. So, thank you so much. If you have any questions at all about this week's lesson, please reach out to your teacher.